Hello. In this video, we're going to be taking a look at Investigation 3, Scaling Perimeter and Area. And more specifically, we're going to be looking at 3.1, which talks about these Rep-Tile Quadrilaterals. So first of all, let's figure out what a Rep-Tile is and what a Rep-Tile is not. Because throughout this investigation, you're going to have to determine if shapes create these things called Rep-Tiles or if they cannot, or they have the inability to create these things called Rep-Tiles. So first of all, this right here on the left with all these hexagons, this is not a Rep-Tile, but rather this is what's called a tessellation. This also, with all of these squares, is a tessellation. Okay, so both of those are tessellations. However, only one of them is what we call a Rep-Tile. And this series of squares is a Rep-Tile, and here's how we know, and this is why we call it a Rep-Tile. So you notice one of the little squares is repeated to make and put together to make a larger square similar to itself. So you have these 9 squares that were put together in a way that create then this outer square that is similar to that original small square. Right? So that's what makes this a Rep-Tile. With these, you cannot make Rep-Tiles from these hexagons. So these are 6-sided honeycomb shapes. You cannot create another hexagon, larger but similar hexagon, from these hexagons. You can't do it. It's not possible to make a Rep-Tile. Yes, it's a tessellation. However, it is not what we are looking at and studying in this investigation, a Rep-Tile. So when you do a Google search for Rep-Tile, these are some of the ones that come up. Here's a good illustration of a Rep-Tile. So you notice on the very left, right here, let me be able to write on this. So right here, this is a shape, and then you notice to the shape to the right of it, it's the same shape, but within that shape, you have other shapes that are similar to that one. So in fact, it's made up of 1, 2, 3, 4 other shapes that are similar to that one. And then if you go one more, now you have all of these shapes in here that are all similar to the larger outer shape that we started with. This is an example. These are all examples of Rep-Tiles. So this is probably the simplest Rep-Tile, and then here this is a very complex Rep-Tile, but if you zoom in far enough, I'm sure you'll see that they're made up of all shapes that are the same, like this, but just really small, and they get bigger as they go on. And you can even see right here, right, they took that and they just kept breaking it up into members of the same shape. All right, so this is an example of a Rep-Tile. Here's another example, and in your homework, you are going to be asked to do this as well. If we take a look at these sort of figures here, so these are quadrilaterals, some of them, not all of them, more specifically looking at the ones in the top left. Those are quadrilaterals, and those are quadrilaterals are not squares, they're not rectangles, and so those are some examples of you can put them together to create similar shapes. So they look like they're the same size but different shape, but they're similar to each other. Okay. So we went over examples of Rep-Tiles. Make sure that is in your notes for 3.1 so you know what a Rep-Tile is, and maybe put a few examples of the ones that I've shown you in there so you're able to identify. Because you're going to have to answer questions like, hey, here's a shape. Can it create a Rep-Tile? And you have to know what a Rep-Tile is first. Okay? And put this definition in your notes too, the term congruent. A lot of times we, in mathematics, especially geometry, use this term congruent to say that two shapes are the same size and same shape. Meaning up here, right, these squares here, so this square, this square, this square, and this square are all congruent to each other. It's not congruent. Those 4 are not congruent to the bigger one, because in order for them to be congruent, they have to be the same shape, same size, same exact thing, right? And so the idea of a rectangle, or the Rep-Tile, is you're taking all these congruent shapes, putting them together to make a larger, similar shape. Now let's go ahead and start in on answering some of these problems. So you need your shapes set sheet that was either handed out to you in class or is available on my website. Make sure you go and print that off. This is what it looks like. And this is important because you can use some of these to trace them on your piece of paper. Like for example, on J, if it says, hey, take rectangles and make a Rep-Tile from rectangles. So you can use this shape right here and trace it and make other rectangles in the same size, same shape that are congruent, and make a Rep-Tile using that. Or this is a parallelogram, you can use that. There's also 3.2, we're going to be looking at triangles, and then throughout the unit we're going to be looking at some of these other shapes. Okay, so that when we're looking at your shape sets, you're looking at these. So you're copying or tracing or something similar to looking at these shapes here. All right, so first of all, you're supposed to sketch your own, or you can use, like I said, this shape set. Okay, so you can use the shape set to make several copies of these shapes. So the non-square rectangle, so that's the rectangle J that I showed you. A non-rectangular parallelogram, that was the other one that I highlighted. So it can't be a rectangle, it can't be a square. It has to be that parallelogram, and we've talked about what the properties of parallelogram are. So look back in your notes for that. And then a trapezoid. Right, and we looked at trapezoids at the beginning when we were on that website. We saw an example of a Rep-Tile using trapezoids. So go ahead and use those shapes, right? So figure out which of those shapes did you draw that you could possibly make Rep-Tiles, and then sketch them to how you would put them together. So go ahead and draw one of each, a non-square rectangle, non-rectangular parallelogram, and a trapezoid, and sketch them, and then come back to the video. So if you're stuck, you're doing something like this, right? So here is a trapezoid right in the middle there. So there's an example of one small trapezoid that is put together, right? Those congruent trapezoids then make a larger, similar trapezoid. So you're doing something like that. Here are just some examples of what you could do. You didn't have to do any of these, but you know, for the first part, here's your rectangle, and then you put 4 of them together to create a larger, similar rectangle. So that could be used as a Rep-Tile. Here's your parallelogram. So that one parallelogram was put together to make a larger, similar parallelogram. And then here's a couple examples of trapezoids, the ones similar to what we saw on that website. So those 4 little trapezoids combined together to make one large, similar trapezoid. Okay, now let's look at part B. Now that we have all of our shapes sketched and drawn, let's look at part B. Number B, part 1, right here. What is the scale factor? So you're looking at the scale factor from the original. So that's the smaller one, right? That's the smaller one to the larger figure. Explain your reasoning. So that really depends on what yours is. But let's look at some of these that I just showed you. So here are some of the ones that I showed you. They're all very similar to each other, so they're going to have similar answers. So on the first one, right here, you have one rectangle makes up a larger, similar rectangle. All right. So this one rectangle right here, and you put 4 together, you would think the scale factor would be 4, but remember the scale factor is you're looking at side lengths. So for this side length, if you look at the new one, the new side length of the larger one is actually twice that, right? So this side length is 1, and then the new side length is 2. And so if you look at that scale factor, to go from a side length of 1 to 2, well, that's a scale factor of 2, because you went times 2 to get to that. All right, so for this one, the scale factor would be 2. Go ahead and do that for your shapes, if your shapes are different. And if you look down here, this is going to be similar. right? And you're looking at congruent sides. So for example, if I trace these two trapezoids right there and look for a side that's similar. So for example, you have this side and this side are similar to each other. So that long green side and that little yellow side are similar to each other. Now we look at the scale factor. Well, look, let's say that this was 1 unit. Well, now the green one is 2 units. So this also has a scale factor of 1 to 2. So it has a scale factor of 2. Okay? And in fact, it's true for all of these that I have here. Those are all scale factors of 2. And then the perimeter of the larger figure. So it says the perimeter of the larger figure. So it's important you get the order. And perimeter of the larger figure relate to the perimeter of the original figure. So you're going large to small, right? So the perimeter of the larger figure, let's take a look at that. All right, so if we take a look at the larger figure, okay, that perimeter and the perimeter of the smaller figure. Now what you would need to do is you would actually need to take your ruler to measure these, okay? But I'm going to say, let's say that for the smaller one, this is 3 centimeters. And let's say this is 1 centimeter, all right? For the larger one, when I go and measure it, I should find out that from here to here, it's going to be 6 centimeters. And then from here to there, it's going to be 2 centimeters, right? Because I know if the scale factor is 2, the perimeter has a scale factor of 2 as well. So when I go through and add them together, so the perimeter of the large one is going to be 12, 13, 14, 15, 16. And the perimeter of the small one is going to be 8 centimeters, right? So now it's asking what's the scale factor from the bigger one to the smaller one? That is a scale factor of 1/2. Because from small to big, it's a scale factor of 2, but from big to small, it is a scale factor of 1/2. So in fact, all of these, if you had scale factor, let's say up here, you had for one of them, you had a scale factor of 3. Down here, the scale factor is going to be 1/3. But for us, it was 1/2 because up here I had a scale factor of 2. And so down here, the scale factor was 1/2. And then number 3, how does the area of the larger figure relate to the area of the original? We should know the answer to this as well, but let's go back to our shapes to find out. So if we look at the area of the large one, it's going to be length times width. So 6 times 2, that gives us 12 square centimeters. And if we look at the area of one of the small ones, and that gives us 3 times 1, so that's 3 square centimeters, right? We should have already known what this answer was going to be because it's asking to compare the area of the larger to the area of the smaller. Well, listen, remember, if our scale factor is 2, for the sides and perimeters, remember the scale factor for the area, scale factor is going to be 2 squared. It's going to be whatever that scale factor is squared, meaning you just multiply it to itself. So if you had 3, it would be 3 times 3, right? So we should have taken the scale factor for the area and multiplied by 4, or the perimeter, or sorry, this is area, isn't it? I'll get it right. So if the area of the small was 3, then we multiply that by 4 to get the area of the large. But if you're going large to small, so you're going big to small, it's times the reciprocal of 4, so that's times 1/4. Okay, so our scale factor in my examples here, this one is 1/4, and in fact all of them are going to be 1/4. Again, another way you can think about that is the area of 1 Well, it's multiplied to itself 1, 2, 3, 4. So now there are 4 of them. So the area is going to be 4 times the size of the area of one of them. Okay, same on all of these. 1, 2, 3, 4. So you would take the area of 1 multiplied by 4 because there are 4 of those shapes in there. Okay, so even though our side length changes by 2, it doubles, our area changes by 2 squared, which is 4. Okay, so for our examples, it changed by a factor of 1/4. And then part C, extend those reptile patterns you drew for question A. Do this by sketching additional copies. So basically you're drawing more of those smaller reptiles to create more or a larger similar reptile. And that's similar to, if we go back to this website, this one right here. So you had created this middle one, and now you're creating one more like that, or this, or this, or this. Okay, so that's what you're doing for this one. Pause the video, do that, and then come back. I would say try it for one of them. At least one of them. So here's an example. If you take the rectangles and put them together, here you go. And you have one small rectangle, which is represented right here. Let's say that's 3 and 1. And then you would have a larger similar rectangle. And we know it's similar because it's made up of a bunch of rectangles, smaller, identical, or congruent rectangles. And so then I know that this is going to be 9. So from here to over here, that's going to have a length of 9. And this is going to have a length of 3 from there to there. Right? And you can even compare perimeters and areas. So the scale factor for the perimeter, if we look at both of these, the scale factor for the perimeter is, well, look, you took 1, 2, 3. So now it's going to be 3 times. So if we're going from the original to the larger similar one, the scale factor is 3. Now if you look at the area scale factor, remember it's going to be that scale factor squared. And we can even double check and count the number of rectangles in here. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 3 times 3 is equal to 9. So the area changes by a factor of 9 when the perimeter changes by a factor of 3. Perimeter or side length even. So this is also side length. So side length / perimeter for that scale factor. Now depending on the shapes you drew, like here was another one, now it's changing by a factor of 4. So the area would be 4 squared or 16. And if you count how many of these are in here, there are 16 of those rectangles. So the area changes by the square of the scale factor. Make sure that's written down in your notes somewhere. That's really important. We've talked about that a few times. It's come up a few times, but write that in your notes and highlight it again and again. And 2 and 3, we already talked about looking at the scale factors. What do those scale factors tell you about side length, perimeters, angles, and areas? I guess the one thing we didn't talk about was the angles. But remember, if we are creating similar figures from smaller congruent figures, remember, similar figures, no matter how much larger, how much smaller, the area, the angles always remain the same. So if you're using a bunch of congruent shapes to make a larger shape that's similar to itself, the angles will remain the same. The areas are going to be whatever your scale factor is squared, and you would figure out your perimeter and length scale factor, just like what we did. All right, so that is all for Rep-Tile Quadrilaterals from 3.1.